Hey, Ronnie here. Shall we make a game? And we're nearly at the end of this. We're at day 59 of 60 and... Oh, hey, how's it going? Um, so, yeah, we're currently fixing up the... Oh, God, I'm blank. Yeah, I'm good, thanks. We're currently reworking the sort of like the web runtime, the bit that... Basically a website that takes in the WebAssembly module and runs it. And last time we had it crashing basically all the time. However, I since realized what that was and I fixed it. And it's something that kind of surprised me. It was, where is it? This here. So when you're making an image data, you're basically kind of like taking an area of memory and saying, this represents an image. I was expecting that, say, if you had 2 megabytes of memory and you told it, oh yeah, just take the first 1.5 megabytes, that it was going to, you know, just ignore the half a megabyte you're basically sort of wasting off the end. And no, it has to be an exact size match for some reason. But then I tried to fix that by doing this, by making a new kind of array out of the previous array. And it still wasn't fixing it. And it turns out that if you don't specifically tell it to make an array out of the buffer within the array you're kind of making an array out of, it doesn't actually change the length. So it was still coming through as like, 2 megabytes and going like, what's this? What are you giving me here? Okay, so next thing we need to do is we need to update the pointer state. So basically we need to update the kind of memory representing the pointer. So I have, just for the sake of convenience, got the old version of it here. Now this did have a bug in Edge, which we're going to try and fix. Let's just open Edge. See if we can get that fixed at the same time. I have actually gone... Oh, I haven't got auto switch set up on Edge. Oops. There we go. So this should run kind of the same as it does in Firefox. Let's have a look. Go away, Edge. Okay, so that's it running under Edge. That's nice. Okay. Let's see if we can find the cursor stuff in here. So we've got cursor L, cursor Y, cursor X. Yeah. Okay. Yeah, I remember this now. The reason we have to store these and then kind of pass them down, because in this version of the engine, the cursor data was kind of like passed in when you called an event. So say like you were updating the game state, you go update the game state, here's the position of the cursor. Whereas in the new version, they're stored in buffers, so they're basically kind of you can basically just put them in that memory and leave them there. And then when we actually execute the event, they'll still be there. They'll still be kind of filled in. Okay. Let's go find the bit where this actually, Okay, here it is. We've got these event listeners. Oh, actually, I think these still exist in the new one. I just haven't connected them to anything. Yeah, there they are. So I'm going to check in here. Because this layer X and layer Y, what were these? I don't remember. It turns out it's an overloaded term. Thank you. There you go. Mouse event layer X. Oh, okay. Oh, I didn't realize this wasn't nonsense. That may be why it's not working in Edge. Yeah, returns the horizontal coordinate event relative to the current layer. So I was expecting that to, if I've say got this, 320 by 180 canvas being scaled up to fill the display, I was expecting that to scale the mouse coordinates, and it was doing it in Firefox but not in Edge, so that's not going to work. So we do have offset, and I'm wondering if maybe I need to scale these. So if I just print these out, and let's rebuild that, and let's see what kind of figures we get out the other end. So bear in mind this display is meant to be, the width isn't on there, that's interesting. It's meant to be like 320 by 180, so we should, hang on, give me a second, let me just check that I haven't set a safe error up, because I think I might have done. Oh wait, I've got it zoomed in, haven't I? Nope, that's not it. Why is it going to 300? That's kind of weird. I'm pretty sure this area is wider than 300 pixels. Pretty sure. Let's have a look. Yeah, it's like 800. That's kind of weird. Okay, let's have a look at the same thing in Edge and see how it looks. Let's get the window sized up nicely. There it is. That also goes to 300. That's kind of weird. And hang on, there's a bit of a border on the edge where it's not. Oh, let me just fix that. Actually, you can't see my mouse. Despite the fact I have capture cursor enabled. Great job, Edge. Thank you, Edge, for. So it works in Firefox. But yeah, there's some kind of border around the outside of that. That's kind of weird. I wonder why that is. I've definitely got a scale set. And just pull this up. I wonder if it's mismeasuring the size of this window somehow and how that's happened, because it definitely wasn't happening in the last version of the engine. Okay, so we've got the calculating the scale there. We've got the number of window columns. Let's just print out what we have here and make sure what we're getting out of here is actually how big the window is, because it might be doing something weird, like taking into account like margins or borders or something. And the other thing I'm going to do is I'm going to put a background color on the canvas, just so I can see the space it actually covers. Because it might be that the mouse isn't going to the edges, but the canvas is covering the screen. Let's find out. Nope, that's definitely not covering the screen. And if I scale it up and down, it's definitely leaving a pretty consistent amount of gap either side. That's weird. I would have thought I would have noticed that yesterday. Okay, so this is saying 818, and our window is indeed 818. So I'm just going to comment on that for a second, because we're dealing with like the, can't really position the mouse correctly until we've got the display kind of positioning correctly. So I'm just going to slightly bump the scale up and see if it fills the window when we do that, because it might be miscalculating the scale. Oh. Okay, yeah, so it looks like it might be miscalculating the scale. It's taking so we're trying to figure out how big a pixel should be based on the width and height of the window. So window columns is the inner width, window rows is the inner height. We know those are correct. So then it's dividing up by the safe area. The safe area should be... Yeah, the safe area is the same size as the display, so... What are we doing? What are we doing wrong here? I guess we start printing stuff out and see if we can figure out where the discrepancy is, because there's definitely something not quite right here. I was not taking this much time and care last time I wrote this. I was, when I wrote the kind of prototype and kind of reworking, it was a bit, should we call it RAD? Should we call it, rapid application development? It was, it was very quickly put together. Whatever would put pixels on the screen, regardless of whether it was correct. Come on. There we go. Oh my, that's a lot of text. Okay. But we can at least grab grab all of this and have a look at it out of context. Oh, it's copied over some random IP addresses. Thank you for doing that, I guess. Okay. So it's looking at the number of rows on the screen and it's calculating a row scale of 7. Yeah, that makes sense, because it's probably looking at this and going, well, I could, looking at the y-axis, I could actually scale this up really big to fill the screen. That makes sense. And then it's looking at the number of columns in the window, which is 818. And just double check that. Yeah, the window is definitely 818. Just make sure there's no like margin or padding or anything interfering with that. I think I've got some style at the top that should be I don't think the margin and padding would count towards the inner width of the window though. Anyway, 818, and then what do we reckon? It is, and then based on that, we're calculating a scale of 2.55. So that should be, and it sounds about right, 818 divided by 320 is, I've got some calculation programming mode. So it's, I need this, it deals with integers. Yeah, that's indeed correct. Okay. So something else is going wrong when we're calculating the resulting size. So is it maybe this? Are we, because this is actually quite a complex bit of, a complex bit of logic here. Are we miscalculating the actual size of the window? Well, so the actual size of the kind of like render viewport. So we're most interested in the columns for now, so we'll print those out. Whatever bug we find in the columns probably also applies to the rows. That's coming out as 320. That's kind of interesting. And we're setting a width and a height based on the rows and columns. Yeah, that should be right. We set a width. Hang on, let me just clear this console. Where's the clear button? There it is. So let's just confirm in here. We're definitely setting the canvas width to. Wait, I wonder if it's a scale thing. Let me just check I haven't got the page zoomed in or out. No, I haven't got it zoomed in or out. Sometimes that can cause rounding error that can be like a bit of a problem. Set the canvas width, and also we're setting the transform, and we're going to get that as well. I'm just going to compare them and do the math and make sure it's coming out at the right size. Because this is coming out at only 766, and it should be 818. So yeah. Oh, is it never hitting? Hang on. It's never hitting this. What? What? How is it? Oh, I know what's happening. I know what's happening here. Right. So this is being pre-initialized to, because this will be, if we go into the video buffers, yeah, it's being pre-initialized to the maximum value. So this is seeing this and going like, well, it hasn't changed. It's already, the value that I'm comparing it to is already like the width of the screen. So it's not applying that to the canvas. So the canvas is using its default like width and height of, I think it's 320 by 150. And you scale it up and that nearly fills the screen, but not quite. So, what's the best workaround for this? I guess I could temporarily just override these with just garbage so that they get corrected later on. Wherever we set the canvas, we'll do it there. Man, I need to start splitting this up into files, don't I? This is just too much garbage. Oh, actually, where's canvas visible? Yeah, we can do it there. Yeah, we can use that. Yeah, so if the canvas isn't visible yet, then we know we need to resize it. There we go. Now it fills the screen nicely. Let's get rid of all that console.logs. That's one bug crushed. That's a good start. Fixed canvas being missized if not cropped on startup. Very nice. Okay, next up we're looking at the mouse pointer, right? So these values should be correct now. I don't know why I originally used layer X and layer Y. I don't think I streamed the development of that originally, so like I wouldn't have a VOD to go back and look at and judge. But that looks right. It's actually, getting me the coordinates of where the mouse would be roughly. Let's do the same thing with Edge. Edge seems to do the same thing. So that should be fine. Yeah, I don't really know why I did that any other way. Okay. Let's set our pointer state to, actually, I should probably only set these if, hang on, I should probably only set these if the pointer state isn't null. So that way we're not setting mouse events if you don't have a mouse pointer in your game. Okay, is there anything else I want to do here? I'm trying to think. Right, there's a style in here actually for the mouse. Where is it? Yeah, there we go. We actually want to hide. We actually want to display the mouse unless we don't want to hide the user's mouse unless the game is going to be rendering its own cursor. So where's that style bit? Here it is. So it's going to be cursor. Sorry, pointer status. Point state. It's null. Then don't put anything else in. Otherwise, put in cursor. Wait, it's not transform. It's not transform. What am I doing? Canvas element. Oops. Dot style. Dot cursor is none. I think that's right. Yeah, that's working. Okay, that's nice. Okay. Let's go back to our event handler here. And I am just going to bring up the protocol documents, actually. This is one of the nice things about actually documenting this kind of thing, is I now have something I can refer back to. And oops. No, I don't own GitHub yet. Just one piece of it. Here we go, the protocol. Pointer states. So yeah, we've got 0, 1, 2. North is no pointing device not available. It's not a mouse. And let's put this held down. Okay, good. So if the mouse moves, we know where the cursor is. So if the pointer state was previously not known, then we now know where it is. And instead, I'm actually going to keep a flag of whether it's clicking, because you can actually drag the mouse outside the viewport. In which case, we don't know where it is. It's not clicking, but you could drag it back in, and it would be clicking. So yeah. So that's 2 or 1. Okay, and then we're also going to copy over the pointer row. Yeah. And I think you can make those optional too. So if you had a game where you're just detecting whether the a game where you can just click anywhere, you might not bother importing like the mouse coordinates. You probably would, but and do the same for the column. Okay, that should be good. Why did I never do these for mouse up and down? That would have made sense, actually. The only one I wouldn't do it for is mouse out, because I think at that point the event might not be what you think it is. Actually, I think there was a reason I didn't do it in those. Yeah, I think it's possible for like mouse up to actually fire with the wrong, because this offset X and Y at the moment is relative to the canvas, but you might not necessarily be over the canvas at the point of mouse up. I'll put it mouse down though. Now I forget whether this clicking thing actually, whether this mouse up actually fires if you drag it outside the canvas. We're going to try that in a second. Okay, there we go. And we're just going to need our event there. Okay, let's see what happens with that. I just want to see whether this mouse up still fires if we drag outside the canvas and let go. Helps if you refresh. So, no, it doesn't. Okay, all right. So it, yeah, it definitely needs to stop clicking, as it were, when you drag outside. Okay, that's good. That's fine. Okay, so if you move the mouse and the mouse position wasn't previously known, it's now known, and then we fill in the coordinates. That's fine. If the mouse is clicked and... Why did I have this? This is wrong. If you press the mouse button down, then it's definitely clicking and we definitely know where it is. If you drag the mouse out, we don't know where it is. And if you release the mouse, and we were previously clicking, then it's not clicking, but we still know where it is. Okay, that should be good. We're not going to really be able to test that until there's a bit more, until there's a bit more sort of code in the game side of it. But I think that'll do for now. So let's just make sure it doesn't crash before we check it in. Yeah, it doesn't crash. That's good. Let's get rid of our red background as well. And there's one more element that we're going to stick in, but we're not really going to test, which is the audio. So audio is kind of complicated because we're inside a web browser and they can't do anything simple inside the web browser. So we have our audio context. So this gets really complicated because you can create an audio context at any time. However, it probably won't work. And the reason it probably won't work is that any audio context created in anything other than direct response to user input, such as clicking or pressing a keyboard key, will be a completely silent, muted audio context that does nothing. Google did not break any web games at all by doing that. Nope, none whatsoever. Interestingly, because gamepad input isn't event-driven in the browser, that means that a gamepad cannot create an audio context. You have to make the user get up and press buttons on the keyboard or click the mouse to be able to play audio if they're using a gamepad, which is absolutely fantastic and not at all terrible user experience. Okay, so that's my little rant over. Let's let's get back to what we were doing. An audio context, we're just going to start as null. And in here, we're going to have it so that if we have an audio context, it gets deleted. Yeah, I actually wrote a note there to make sure I didn't forget. Okay, what's involved in deleting that? It is... Oh, just call close on it. That's nice. And yeah, I'm going to reuse this, I think. This is a pretty good little function. Let's put it right below where we're actually using it. Where is it? There it is. And we're not using shutdown tasks this time. We only need that because last time the kind of shutdown sequence of the game in the event of an error was kind of complicated. It no longer is, which is good. It means we've cut out complexity. Let's move this up a bit so we can call this from our kind of like mouse events over here. Yeah, let's put it there. That's a good place to put it. And also, we want to make sure that we actually have a audio samples. Yeah, audio samples. Because if the game has no audio, we of course don't want to make an audio context. That makes no sense. And actually, I'm going to move that condition to second place, even though there's of course no performance benefit in the real world. We want the first condition that's likely to fail to be at the beginning of the list. I don't know if JavaScript will actually honor that or whatever, but like, well, JavaScript runtimes will honor that or whatever, but it can't hurt, can it? Okay, mouse down. This is where we create our audio context if it's missing. And so one of the complications with this is creating the audio context actually starts the, and this is part of the reason that you can't just create one and let it be muted. When the game is just kind of running with no audio, it's kind of synchronized to whatever clock, this timestamp is kind of synchronized with, which is fine. Nothing wrong with that. The problem is that I want the gameplay to otherwise be synchronized with the audio clock. The reason being that if you have, say, stuff timed to your music, you want it to line up perfectly. So it actually needs to be able to switch which clock it's using kind of mid-run, which is kind of complicated. And why I'm doing it at the platform level and not anywhere else. So I'm just going to go into the project settings. I've got timing here, and I'm going to reduce the ticks per second to like 3. So we're going to be able to see these individual calls to tick. So we're going to put a console login here, and when this is finished thinking about it, there we go. And that's not working. That's interesting. Okay. All right. Let's print out how far we are through the current tick. This should be going up. Oh, it's not hitting it at all. That's interesting. Ah, I know why. If the previous timestamp isn't null, it's only ever remembering the last timestamp. In the event it already had one, so it's never going to have one. Okay, that looks like it's going too fast. Let's find out. That looks like it's ticking every frame, which isn't right. Yeah, that should be doing 3 a second. That's doing way. Oh wait, I didn't rebuild the application. That'd be why. I didn't, I edited this code over here to say like, oh yeah, reduce the tick rate to 3 per second, and then didn't actually compile this. This was still loading in like a 60 hertz game and then going, I don't know what you want from me. That's more like it. Okay, so next up we want to, yeah, okay. I think audio context has a time in it. Let's have a look. It's been a while. This was a part of my previous attempt at this that had a major bug, so I'm not looking to replicate this part. There's another thing as well in that the I'm pretty sure that the audio context can be kind of like suspended by the background and by the browser. So I want to double check that. Audio context, lifecycle, browser. Yep, that's fine. Things that are not ready yet. That's promising in a document written. When was this written? Oh, I was kind of hoping this would have a, hang on, view the source in GitHub. When was this page written? I bet it was a long time ago. Oh, it's only like 2 years old. Okay, I'll give you a pass on that. But still, like, the audio context API is like, it's got to be going on for a decade old at this point. It's like, things that aren't ready yet. And I'm pretty sure it can be, I mean, maybe it's just WebGL that can, but I'm pretty sure that web audio context can be destroyed by browser. Hang on. It's saying here that you can, I didn't realize that, you can create it right from the beginning and then just resume it. That'd be handy. Because I might just create it anyway and then resume it later on. Yeah, I'll do that. because that means it'd be resilient to kind of like, you know, being paused and stuff like that. That'd be nice. Okay, so there's gonna be a resume function in here, right? Offline audio context. What the hell is one of those? Oh, okay. I didn't know that existed. That's really nice. That means you can, you know, if you were, say, building, it actually opens some possibilities. So at one point, I'm sure someone's already built this. I was thinking, like, what if someone built pretty much like, you know, a DAW, like Fruity Loops, directly in the browser? And like, well, the hard thing would be, how would you render it out at the end? You know, because you could build like all these really complex graphs of like nodes and stuff. But if there's a way to build an offline audio context, that's really nice. It means you can actually use that for your rendering side. You know, you can, and if you've got something that's really computationally expensive, you could use this to kind of like render into kind of like proxies. That'd be nice. Almost like in a video editor. Anyway, so this is asynchronous, so we do need to keep that into account. We do need to take that into account. Is there like a state we can check, because we're going to be doing polling here, nothing else really? Is there a way to get the state? Audio context, get state, because that way we can know if it's been paused or something. Oh, there is one. Suspended, oops. Suspended, running, or closed. The audio state changes to interrupt. Okay, this was the thing I was talking about, yeah. In some browsers, when you kind of tap away, it can go like, oh yeah, you're not using this at the moment, I'm going to pause it. So yeah, I mean, despite the fact that it's a string, possible values are suspended, running, or closed. Oh, by the way, it can also be interrupted. So it's not just those three, is it? It's also that one. Oh no. Why are web browsers like this? So yeah, we can instead just go into here and be like, audio samples, new audio context, otherwise null. Oh, hang on, we also want to check this, because I might be wrong on this, because obviously, you know, if you can get this far, you at least have WebAssembly, which implies you're on a modern browser. But then I think it might be the case that some browsers will actually lie about whether they have an audio context, and will just like hide it from like client code, because they'll be like, well, you know, we don't want you to use it, so we'll just tell you it's not there. I could be wrong on that though. I mean, like, you see here, like, browser vendors are not afraid of just going, we know your rules are this, but we're going to do this instead. I mean, why did they even do this? There's already the ability to there's already a suspended flag. Just use that. That's what it's there for. Okay. We're gonna change this to resume audio context if. Yeah, I'm just gonna call it that, because there's a number of conditions that could cause it to become paused. Okay, so if we have an audio context, we then do a switch on the state, and it can be suspended. Oops, hang on, .state. See, here's the thing. Despite the fact that, you know, this is apparently common knowledge, and, you know, yeah, and like iOS, Safari, browser statistics. Like, it's a pretty common browser. Yeah, it accounts for like nearly 20% of like all browser usage worldwide, right? It's not in the TypeScript types. So if I was writing TypeScript here rather than JavaScript, I'd have a bit of a problem. So interrupted is one. In both of those cases, we basically need to say, actually, you know what? No, actually, I am going to keep it in here. I might also put this into the main render loop. So if it's, So if you're running on a desktop and it gets interrupted or paused or something, it can still, restart. We're going to make this throw in the event that we don't understand what's going on. So if it blows up, we have something nice and clear in the logs we can look at and we can figure out exactly what went wrong. And just in case it's changed, I don't think it can, but just in case it does change between, there's that whole thing of time of validation versus time of use. What's it called? Time of validation versus time of use. Time of check to time of use, yeah. We don't want to check it, go, oh, we don't understand what it is, and then go, here it is, it's something that we would actually understand. I believe this was actually a bug in certain Game Boy in the Game Boy BIOS, because it did that thing where the Nintendo logo came down, and it used the Nintendo logo to verify that the game was licensed, because obviously Nintendo holds the trademark on that logo. So people made cartridges that would present the right logo first when the game actually did the check, and then when it came to displaying it, they'd display a non-trademark logo, which is genius. I put 3 R's in there, that's wrong. And what else do we have? We have running. So if it's running, we do nothing, and it's either of these. Let's resume. So let's put this all the way down here. Yeah, let's put it there. Seems like a good place to put it. We'll put it somewhere. And just thinking about this. Maybe we actually have that a bit higher up. So we do actually need to be able to detect when the audio context gets lost. I don't think that can happen while we're interacting with it. Because when that happens, we need to... actually, I wonder if... it doesn't actually say here that an event gets raised. So we might not even get notified when this happens, which is, great. So we need to keep a track of the last timestamp we got out of the audio context, so then we know how much time has passed. Previous audio context time is going to be null, and we're going to reset that to null if it gets interrupted or suspended, just so that we've kind of detected that and we can kind of not process it when we shouldn't. So we get to here, and where's the bit where we do the timing? We're up to print state, that's fine. So here is the bit where we need to do our complex audio timing. So we at this point need to do a switch on the audio context state. We need to check if there is an audio context actually. And there's going to be so many bugs in this where like you have like certain buffers missing, it does weird things. They get shaken out with time though. It's fine. We'll figure it out. Let's just copy this because we want basically all the states. And we're going to put a flag in here saying timed by audio system. And then if we get to here, timed by audio context is true. Most of the time, we are going to be timed by the audio context, I think, in most real world circumstances. So I'm going to put that in there. Oh yeah, we never actually put that. Never actually used that state we recovered. You go in there. Okay, so at this point, we can set the previous audio context. Okay, so now we have the time. Oh, it's saying I can't declare things in here because it's a case. Always found that a bit weird, but okay. Actually, you know what? I might actually replicate. I might actually take this out and put it. Get rid of that and put it there instead. Why not? Anyway, so yeah, now we're coming to here and the audio context is running, and we get the time out of it, and we compare it to the last time if it had one. If it doesn't, then we go like, it's still not. We're still using the kind of like render loop to time things. Otherwise, we now have the amount of time that we need to pass. So I remember this being a bit fiddly to do in the old system because let me just bring Sprite up and kind of explain this kind of visually. Yeah, let's explain some audio stuff visually. It seems like a good idea. You got your sort of timeline here, right? We get like a tick, 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 and time is constantly passing, and your code may run, it may not, who knows. So we're basically going to get a buffer out of the game, and we're going to put it in here. You then need to render kind of one ahead, so that if you'll say here, and next kind of like opportunity lands here, you've definitely got audio kind of queued up. So you actually want to have one audio buffer queued ahead, which means you have to remember exactly where you started the last audio buffer and then place the next one exactly one buffer ahead of it, and so on and so on and so on into infinity. One of the annoying things is you can't reuse these buffers. You have to allocate a new one each time, which means that at 60 frames a second, we're actually allocating 60 audio buffers a second, which is not great. It's not ideal. It's not optimal. Chrome does let you reuse them and refill the contents. Firefox doesn't, for some reason. So yeah, we basically need to come into here, and we need to at this point check if a tick has passed, and we might want some kind of clamping on how much time is allowed to pass, or the amount of ticks we're allowed to render. Because while it's not ideal that we might, if say, let me just draw this out again. It's not ideal if, say, we go from here to here, and we've got the ticks like here, 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 here. And let's say that we were previously on this frame, and suddenly we find ourselves on this frame. We've skipped over like a ton of these ticks for some reason. It's not ideal. It's not ideal. Now we could try and catch up with these, but if the problem is the system is overloaded, that just means you're going to get more overloaded, because processing these will take more time than you've got left in this tick. So it's actually better to let the game run more slowly than it should, and possibly have like an audio pop or something. It wouldn't be ideal, but at least that the game will kind of stay responsive, and you won't get that kind of snowball effect where one bad frame means the game never recovers. So that gets kind of complicated. The other complication is, of course, what happens if your tick rate is really high, like it's higher than, say, the refresh rate of the screen, which actually isn't unreasonable. Think about something like a fighting game or something where the tick rate might be like, over 100 per second, but then people might be playing on like, say a PAL TV that only refreshes 50 times a second. So there's actually a lot of complexity you have to take into account here. We need to measure the approximate time between refreshes of the display, which we should always have by this point, and make sure that the next end ticks are covered. That's kind of scary and complicated, isn't it? Okay, so. And I think also maybe we should have some averaging, some kind of like smoothing, so that we don't end up in a situation where like one bad frame, again, kind of like throws the game off and makes it go, oh no, wait, I need to render like 1,000 ticks. That's not true at all. How are we going to rationally set this up? Because most browsers do actually cap the refresh rate at 60, but not all do. For example, if you're doing, if you're running, say, the MetaQuest browser, I'm pretty sure that can run at 120 because you can run VR experiences in that. They wouldn't run those at 60. It's kind of funny they kept that frame rate cap in there primarily for backwards compatibility and then broke the audio system completely, which I'm still not bitter about at all. All right, okay. Okay. I'm thinking. So we actually want to count the number of ticks that have happened past and cap it to something like 5. So it can't do more than 5 ticks. Yeah, because I can't imagine you ever have a situation like that. I mean, you might have, say, a game with a tick rate of 150, right? And let's say you're running at 30 hertz, that would be 5 ticks. I think that's probably the most extremes you'd ever have, right? I can't imagine someone rendering a game as simple as we're trying to build here at less than 30 hertz. And I can't imagine someone using an engine like this to build a game with a tick rate more than 150 frames a second. That'd be ridiculous. So let's get our delta seconds is going to be the, next audio context time, take the previous context of time. So now we have how many seconds have passed. We're going to clamp that at 0. Math. So that time can't run backwards, even if it appears to. What else are we going to clamp it to? We're going to clamp it to 100 milliseconds because, again, if 100 milliseconds or more pass, that's just a bit, yeah, we're not even going to try and catch up to that. Yeah, okay, I'm just thinking about this, So we then need to divide that by the number of ticks per second. Hang on, is that right? No, I think we need to multiply it, don't we? Have I done this part wrong down here? I think I might have done. Hang on a second. Yes, number of seconds multiplied by ticks per second, yeah. And that should be 0.1, not 100, because it's 100 milliseconds. Increment that, and then tick forward. Okay. I'm just thinking about the best way to kind of carry this forward. So we are going to want to record. Just tell me a good think about this, because we want to get the time at which we're going to stick the next time. Because, like, let's say that this happened, right, and we skipped over a bunch of frames. We don't want it to place the next audio buffer here, the previous, like, time step plus a bit. We want it to place it here. Right, we always want it to be ahead of where we are. So, how do we do that? Oh, actually, there's another issue with this. This assumes that they're going to line up, and they generally will, but not always going to line up, are they? Okay, all right. We ideally want to make sure there's always at least one buffer ahead. So let's just start noting down some things we want to do here. So, requirement. Always have at least one audio buffer ahead of the current time. Requirement. Never place an audio buffer prior to the current time. Requirement. Handle cases where we require multiple audio buffers per rendered frame. Requirement. Sort of gracefully handle cases where the system cannot keep up with the tick rate. Do not snowball. Okay, those are our requirements. Fake them all out. Okay. Let's have a look at the old implementation. The old implementation mostly worked. It just had that issue where it would snowball and it would kind of get stuck in a situation where it was constantly placing down audio buffers. I think I had like a really complicated. Originally, I tried to pull the memory. I tried to make a pool of audio buffers, and that's when I discovered you can't reuse them. So there might be, you know, little bits and pieces that left behind in here. Yeah, here we go. Last audio buffer ends at plus seconds per audio buffer. Okay. Okay, we can calculate that. Yeah, it feels a bit kind of dirty using like floating point seconds to do this kind of thing, but it must work, I guess. So it's gonna be seconds per audio buffer, which is gonna be, where's the tick? Ticks per second, there it is. Where's the first reference to that in the entire thing? It's gonna be there, isn't it? Okay, const seconds per tick. It's gonna be ticks per second is null. Null, otherwise 1 divided by ticks per second. Okay, so we now want to keep a record of, what do we call this? Last audio buffer ends at. Yeah, I want one of those as well. Now, how do we then, we need to then check whether the, oh, we need to know where it starts actually, that's the most important thing. Last audio buffer starts at, that's the most important thing, because then we can check like if we've run over to the next one. So if the next time is greater than or equal to previous starts, no, starts. Oh, and we should probably also clear that when the audio buffer gets reset, just so it doesn't like try and carry on from a timestamp from the previous kind of run. There it is. Yeah, just so it doesn't try and carry that over between kind of runs. Okay, that's good. Okay, so to do ensure that at least one audio buffer is placed. Yeah, I think that should work. I think it should. I think it should. Oh, this is so complicated. I'm also going to want to know where when the first audio buffer is, not just the last one. And okay, complexity here, right? Let's say that we have a timeline, and let's say that we've made a bunch of buffers like this, right? Let's say that we looked at our prediction and we went like, oh, we're probably going to need like 5 buffers, but then it turns out that prediction was wrong. And we need to know how far through we are, how far through this time span we are. So, you know, we have the start of it, we know how long it is. Now, when you roll over into the next one, we need to know where the start and end of this is, but it's not necessarily directly in line with this. And the reason it might not directly be in line with it is that we might have had a slight delay. Oh, actually, we never will them. We'd only ever do them in a line like this if we thought we were going to be behind. Or is that true? I don't know. I don't know if that is true. I don't think it is. Oh, no. Oh, no, I'm losing my damn mind. Oh, actually, something else I've just thought about. Hang on a second. Hang on a second. I just thought of something which would be a bit of a major issue for this. If we are rendering multiple like this, right? Hang on. Right. If we are rendering multiple like this, if the time is here, right? If this is our current time, this line here, and we render multiple buffers, we call the advanced thing like multiple times here, the tick function, to create the game state we're rendering to audio. The game state's now here. It's now in this block, but the game should actually be in this block. So we're actually, yeah, that's we're going to be putting a frame on the screen that you can't hear yet. That's going to be weird. I mean, I guess if it works, it works, but... Oh, this is getting complicated. I guess it's not the end of the world if there's a bit of a skip when you audio context is lost. I mean, not the end of the world, is it? Okay. All right. Okay. So we have the number of ticks we're expecting to have passed, right? If we're... So it just occurs to me, it's actually gotten really complicated. Gotten really complicated. Is that the it's actually the same issue. It's the same issue. You got your timeline like this, right? And this is only, and let's say that we've got 2 ticks. We are currently here, right? We haven't yet reached this line, but we need to render this audio a frame ahead. So we need to advance the game state from here to here. But the timing is still back here. It's still over here. So would we be effectively iterating through this game state at the time we should be iterating through this one? I don't know. Oh no. Okay, I think we do. I think we just deal with it. I think we just accept the fact that there's going to be a bit of a weird kind of discontinuity between where the video and audio are. It's going to be like a frame. As long as they stay sort of locked, we should be okay. Okay, so what we need to do is we need to project. Okay, yeah. We need to take the delta seconds. That's like how much time has passed between this frame and the last frame. I'm not going to look at the text just yet. And expected next time is going to be the next audio time plus the... We're going to average these delta seconds just to kind of like get rid of any kind of ripple. Where's my audio context stuff? I should really be kind of splitting this out into multiple files by now. Let average audio context delta, time delta, that's going to be null as well. And then everywhere that we've kind of set this to null, we're going to set this to null as well. That's good. Okay, and I don't think I'm going to do anything too impressive here. I'm just going to do like a basic sort of linear interpolation. So averaged. So if this is null, if it's our first one, then we just have to, we can't do any averaging. We just have to go whatever we got first is probably it, but it's probably wrong too. Otherwise, what do we do here? Let's do like say a 10 frame average roughly. So average time, the average multiplied by 0.9 plus the latest one multiplied by 0.1. Next time is going to be the current one plus the average. So yeah, that should give us an expectation of where we're going to be next. So we then need to check how many ticks that is. You know, is that going to take us over into the next tick or the next, say, 5 ticks? If so, that's when we kind of... Okay, so we're doing kind of like a very predictive approach here. Right. Yeah, we This does need to be when it ends, not when it starts. That's fine, that's fine. So if the expected next audio context time is greater than or after the end point, we need to we need to advance the game state. Okay, to do tick, etc. And then we're in a bit of a sticky situation because we need that audio, but we don't want to actually advance. We want to render as though the game hasn't ticked. So maybe, hang on a second. Maybe we actually render the display before we advance the game state. That would introduce a frame of latency. I don't know if I'm happy with that, but maybe we do. I mean, it can look like we're going that way anyway. Not sure, not sure. I have to have a bit of think about that. This kind of thing is always kind of so complex and difficult to get right. You see why people use off-the-shelf engines. I'm very, very quickly learning. Why do people use off-the-shelf engines? I'm starting to get an impression of why they do that. All right, okay. Let's just visualize this again. So we've got these ticks and currently here, and I guess we do actually want to render it right as it is. Guess there's no way around that. Yeah. So I think we have a video callback which we can use. Yep. And then I don't remember what we should do to flip it onto the screen. Is it I think there's like just a put image. There it is, put image data. There we go. Yeah, that's simple. How easy, right? At the very least, mouse input should be up to date by that point, I think. Yeah, I'm going to put to do on this. Like, to do, can we... It'd be really nice if I could do some kind of like rollback style thing actually, where I could say like run the game state forward and then roll it back, but can't really. No, I'm going to try and resolve this without introducing any of this nonsense. Let's put that there. And hang on a second, hang on a second, hang on a second, hang on a second. I might be having an idea here. So the game state ends up a frame ahead. I think. Yeah, so to kind of explain what's going on here. So I'm trying to decouple the... So I have a game state system that's based on like discrete ticks. Okay, so like, you know, the game state might run at say 100 ticks per second. And that means that regardless of the frame rate, regardless of how many images we're putting on the screen, the gameplay logic always runs at 100. And the reason for that is it means that you don't get any kind of like bugs at different frame rates and stuff like that. It means that you can just write your code as if it runs at a locked frame rate and it just works. And if your game then renders a different frame rate, either higher or lower, you know, so let's say it ran at like, you know, four times the tick rate, it might look like this. You know, it's going to be like drawing frames kind of here and here. And it uses a bit of interpolation so that, you know, like say if an object is moving from left to right, you basically interpolate between kind of the gameplay frames along those. Right. Now, here's the next problem, okay? Is that I'm basically interpolating between the previous two gameplay frames, right? But I want the audio from the next frame. You might be able to see how that's a bit of a problem, because if I advance the game state to get the next audio frame, I no longer have the old game state to interpolate. Yeah, I can't render a frame halfway through the previous game state if we've already skipped to the next one so we can get this audio. So, can I instead delay the audio by a frame? Because I think that'd be less problematic. Yeah, I mean, like, audio cues tend to be a bit less instantaneous than video cues. You've got things that speed of sound. Quite often, TVs annoyingly have even more audio lag than they have video lag, which is, yeah, even in game mode. Yeah, so I guess this is a tough thing here, the contention between like I want to always have the audio system kind of ready to handle whatever I'm about to throw at it, but I also don't want to be I don't want to have like, yeah, I've got to kind of like, yeah, it's an authority problem. I have two things here trying to control the same process. I have the audio context needing that, you know, nice continuous line of buffers to play through, but I also have this thing where like, you know, I don't want the snowballing effect. I don't want to ever like try and, you know, render 1,000 frames at once because it was trying to fill in for an audio gap. So it needs to be able to predict where the audio is going to be and time the game based on that. Okay, all right, okay. I think I know what I'm going to do. So I can use this, right? Yeah, I can use this like average frame timing to guess, say I'm here, to guess where it's gonna land. Right? And that means that it's going to effectively guess when the next frame's going to land and use that to know whether to render the next audio buffer or not. And then it's going to render the game at that predicted time, meaning that it might slightly, you know, over or under speed, but it should average out. These games are not heavy. They should never really be. I've actually got a performance testing machine over there, which is it's a GeoBook 110 with a 1.1 gigahertz CPU in it, and the idea is that it should always lock 60 on that machine. Any games made with this. So we should never have uneven frame rate. So any potential, like frame time inconsistencies shouldn't really happen. I know that's a very kind of like, sort of weird way of looking at it. You look at like Digital Foundry and stuff, but like this is not the kind of game they normally review. So yeah, we're going to disregard that. And we're going to instead calculate the next audio time we're expecting. And we are then going to use that to anticipate when the next audio buffer is going to be. Okay, all right, okay. Okay. So we now, say that we are, just going to get rid of all these lines. So that we've had frames like this, and we are here, and we can tell by this, the next frame is probably going to land inside there. We're going to advance the game state, and we're going to render it as if we're already there. So basically almost got like a frame ahead in terms of gameplay, well, in terms of video as well. Okay. Yep, that's good. So we then need to check whether it's crossed any kind of like, tick lines. And then we need to render so many, then we need to run the game so many times. We're going to have a cap on it so it can like, only go up to say 5 ticks at once. I think that's probably enough. That'd be like, that'd be 30 hertz at 150. That'd be 30 hertz at a tick rate of 150. Yeah, that should be good. So we now want to calculate where the last tick is going to land. Yeah, just having a good think about this. Just having a real good think about this. So the tick progress is actually going to be, rather than kind of like accumulating it like we did down here with this one, we're actually going to instead calculate it based on the progress for the current frame. I mean, there might be a really weird thing that happens when you switch to having the audio cut from not having audio to having audio, where say like it runs backwards, but it won't actually do anything gameplay wise. It'll just be like graphics wise. It might like say for a frame or two go backwards. Not the end of the world. Not really a massive problem. Actually, I could also put a check in here and make it so it just pauses rather than going backwards, which I think would be better. Okay, so oh, actually, when you roll over into the next frame, it needs to not do that. We can just do that in here. That's no problem. Okay. All right, okay, that should work. That should work. We still need to do the bit up here where it actually just the gameplay ticks, but that should work. Oh, hang on, I need to do one more thing. I need to do yeah, I think I need to do that because yeah, we're taking the timestamp from the end, not the timestamp from the beginning. Yeah, okay, that's good. That's good. And we also need to check in here if it's null. Right. Okay, so we need to take the time last audio buffer ended at, and we need to yeah, we need to basically take the time the previous audio buffer ended at, which should be here, and then we need to advance it forwards until we find one that covers the end of the next audio context. So that's yeah. This one's going to need like float modulo, isn't it? Yeah, it is. So if we oh god, this is like the math was really hard to do while streaming. Okay. Next audio buffer ends at so if it's null, then it's going to be the expected next audio context time. Otherwise, it's going to be otherwise it's going to be oh god, what we need to do? We need to basically take the previous sequence of kind of like we need to add an integer number of okay, yeah. So so okay. Expected next audio context time. Subtract the last time that one ran, right? We need to multiply that by the seconds per tick. Yep. And then we need to round it. Now, do we need to round it up or down? I'm thinking we need to round it up, so we need to ceiling it. Okay. So that's going to get us the number of ticks we're going to run. And yeah, that should be good. That's going to get us the, that's what it reference that, plus that. Multiplied by ticks per second. That must be the other way around, it must be ticks per second. And then seconds per tick, yeah, okay. Okay, all right. Okay, so now we know exactly where we got to be. Oh, actually, no, hang on. Oh my god, this is getting really complicated. Oh no. Okay. Number of ticks to execute is going to be, if we don't know how many ticks to execute, hang on, number of ticks elapsed. Then it's going to be the average time delta multiplied by the ticks per second. So, you know, how much time appears to be passing multiplied by ticks per second. Otherwise, it's going to be this pretty horrendously complicated bit of logic here. Number of ticks elapsed. We're then going to cap that at something rational, like say, It's number of ticks to execute is going to be basically a kind of a safety thing on that, just so it doesn't like run. This is going to stop the snowball effect. The best thing about all this is we don't really have a game to run, so we're not going to know if this is going to work until like probably like weeks away. The best kind of code. We can at least like get a rough idea though. We can have a look at the stuff that's coming out and make sure it makes some degree of sense. Okay, so if last buffer ends at is null, or if we need to extend it, then we're going to run sort of backwards in time. So audio buffer ends at is going to be next audio buffer ends at subtract, probably making all sorts of losses here in terms of like accuracy and precision. The number of ticks to execute multiplied by the seconds per tick. Yeah. Okay. All right. And the number, I guess we should probably also use the number of ticks to execute instead, but yeah, let's use the number of ticks to execute. Number of ticks to execute. That's and to do render audio. Okay. So at that point, we now have audio ticks and audio progress. So we should be able to see in kind of real time, we should be able to see exactly where it's placing the audio kind of driven ticks. If I can go to the right tab, that'll help. Oh, or it could just crash. That works too. Unimplemented audio context state object map. Oh, I know what that is. Oh no. It's because I wasn't getting the state out of the audio context. So I was actually just getting like the state was kind of like the buffers we're using to do quick saves. It's using completely the wrong thing. As much as I ragged on TypeScript earlier for not knowing interrupted was a thing, that would actually that would have saved me from doing that. Okay. Switch state. I think we've got one more of those. Yep, we do. Let's just make it clear that it's not shadow variables if we can help it. Oh, we've got a not number. That's good. Oh, and we've got some weird stray pixels up there. What's that? That looks like we're using the wrong memory or something. In fact, we just got some random sort of blue pixels in there. Are they the same each time? Oh, that's interesting. Whenever I click on the screen, we get a blue pixel. That's kind of weird. Yeah, there's some kind of memory corruption happening there for sure. Something is leaking into the memory we're trying to display. We'll figure that out in a bit. Right, so audio progress is not a number. So what are we feeding into this to actually calculate this? Let's have a look. Console.log. Let's just basically take this entire equation and write out the pieces in here. So we can see what kind of numbers are going through, so we can get an idea of why it might be going wrong. And put this in brackets just so it's clear what's going on. Build, 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 build. Okay, null subtract not a number. That's yeah, I can see why that might be not be working. Oh, that's right. I'm not actually incrementing this at any point. Okay, all right. Okay, let's just comment all this out. And we should be setting this here. This isn't being hit. That's kind of weird. Number of ticks elapsed should be, yeah, versus 5 ticks per second. Oh, hang on, hang on, hang on, hang on. This math.ceil should be in both of them. And actually, I can see a few more places I can reuse this. I can put this ticks per second on the outside. Okay, something's definitely wrong here. Not a number, my favorite. Okay, what is not a number about this? Is it going to be this? Could be. We will get this working. We will have this working. It will happen. Yeah, why is that not a number? That doesn't make any sense. So it's the audio context time delta. Why would that be not a number? Let's just check that's definitely where we're getting that from. Yeah, that's not a number. Why not? So we've got our next, and then we've got our previous audio context time. Instantly, this is the same not a number that JavaScript type of will say is a number. I'm actually going to edit my build script just to stop it making quite so many icons. At the moment, it's generating icons for like every platform, and we don't really need it. Let's get rid of all of them. We don't need any of these. Way faster. Undefined, undefined. That's not right. Is it called something else? Ah, it's called current time, not time. Hey, that's looking pretty healthy. Let's see what we can unearth now. Do you have any other console logs in here? Doesn't look like it. These aren't looking right, but we'll figure it out. I'm actually expecting this to be ticking, and it's not, which is a bit weird. Like if I run the game, I don't directly interact with the audio context. I'm expecting that to show up. I wonder if it's incorrectly detecting this as being timed by the audio context, and it's not. Huh? You're being timed by the audio context, but you're not, right? How can that be? What? It's suspended. Oh wait, I defaulted to full. It's true. Why did I do that? That's obviously wrong. Ah, I'm so stupid. Anyway, we should now, on startup, we should see it start ticking over. So it should, yeah, it's now ticking very, very, very fast, tied to our frame rate. In fact, that seems way faster and it's not responding. So I've done something wrong here. What have I done wrong? Okay, I'm going to assume this delta ticks is like scandalously high. It's completely broken the browser. I'm gonna have to open the new tab. And I can't open the I can't open the thing because it won't let me. Okay, right. Let's just comment out the bit where it actually leaps over because that's obviously wrong. Okay, now we can see it. Don't show again. Refresh the page. Yeah, you've not elapsed 5,000 frames, buddy. That's not right. Is that still happening over here? Yeah, it's happening over here. We've done something wrong. Okay. It's the wrong way around. So it was doing 1,000 ticks per second. That's more like it. So if I then comment this back in, we should see roughly 3 of these every second, roughly. That's roughly 3 a second. If I click, we should then see audio ticks. At the moment, these are going way too fast. There's something wrong with that. Let's try and figure out what it is. This is currently executing one every frame because I did that. Oh yeah, that was kind of stupid, wasn't it? So let's take this back out of here. I don't think that's quite right. So we're gonna want to always do at least 1 tick, so we can render audio. Actually, no, we don't. We can actually render audio without that. Oh yeah, we can render audio without ticking the game. I didn't really thought about that. So we're gonna want it to do like an audio. It's not the end of the world if it does like a tick that shouldn't do. Okay, let's have a look here at the let's have a look at how our time delta is working out as well. We should be seeing roughly 0.016 because this is a 60 hertz panel. We should be seeing roughly 60 frames a second. Yeah, so that's roughly where we're up to. As you can see, it does judge up and down a bit. That's why I've got the average on there, just so it's kind of smoothing out. I might also add a bit of kind of like fudge percentage to it, like say add like an extra like 10% to it, just so it definitely makes it, you know, it's definitely erring on the side of caution. Okay, so the next audio buffer ends at is going to be, let's change this. Let's leave it as last. It's going to end at the time it last ended, plus the number of ticks elapsed, multiple seconds per tick. And the number of ticks elapsed is going to be, let's just work this out because I think this is one of the things I got wrong last time. Huh. I've kind of got a chicken and egg here because on the first frame, it's easier to calculate this one first and then this one second. And on any subsequent frame, it's easy to calculate the other way around. So maybe I actually do like a branch up here instead. Yeah, let's do that. Number of ticks to execute, and the last audio buffer. Given that both of them have a branch of them anyway, it makes sense really. So we always want to execute at least one tick right at the start. We also want to make sure we've got at least one buffer kind of filled up. Actually, wait, these should actually be totally different. Right. Okay. Okay. All right. Okay. Slips my mind here. Right. If this is the first time we're actually doing audio, to do render one audio buffer and initialize variables from the end of it. Render one audio buffer starting now, initialize variables from the end of it. Okay. And then, okay, this works much nicer. So on the first time we come in here and render, we don't actually tick straight away. We instead go, right, just put out one buffer of audio. Just do it straight away. And then we follow through the normal, the existing logic that goes, right, do whatever, additional ticks and audio rendering you need to be able to make it into the next frame without any loss. Okay. So I've got last audio buffer ends at is null. Okay. Otherwise, no, in all cases. So last audio buffer ends at, okay, that's fine. I changed it to previous just so I'm using previous rather than last. Next audio buffer ends at is going to be the time it ended plus, and then we're going to have to do this kind of slightly ugly thing where we're having to yeah, we need to take the next audio context time, subtract that from the time which the last one ended, and then round that up. So we're going to have to do a seal on it, and then multiply that by, and we also have to divide that by the, so we've got the time there, ticks per second. Yeah, so then we divide that by, no, hang on, we divide that by the number of, I'm losing my mind here. Yeah, we divide that by the number of seconds per tick. Yeah, and then we multiply that by the seconds per tick. There we go. Right, so now we know where this is. So now we need to calculate how many ticks we're actually going to render because we might not render all of them. And we're also not going to render any that are now in the past. Okay. Right, okay, yeah, I'm just thinking about this. Number of ticks to execute is going to be the number of ticks elapsed. Okay. Number of ticks we're actually going to execute. We're going to cap that 5 so it doesn't snowball. It doesn't try to say render 200 ticks if say like, the computer goes to sleep or something like that. And if number is greater than 0, then we take the end of a last tick. Okay, that looks about right. In fact, I'm going to turn that into a while loop, and I'm going to make it do that. Oh no, that needs to be an if statement because then we're going to push it back a bit and we're going to roll it forwards. Okay. Output the audio. Okay, all right. And then we also reset the audio progress, the tick progress, so that we don't end up with this doing something it shouldn't. Let's see what that does. I have no idea if that's going to work or not. That is ticking way too fast. Okay, all right. I wish there was a simple way to slow this down a bit. Well, I'm actually nearly out of time for today, actually. I was hoping to get this done, but I guess not. So I guess I'll make a note here of what does and doesn't work so I know what to fix next time. To do. Seems to be ticking every frame. Might be wrong. Well, almost certainly is wrong. And then the next tick progress is... to do. Seems to always be 1, might be wrong. So, thank you very much for watching, and I hope you have a great Sunday. And tomorrow will actually be the final day of what did I call this again? I called it Devteptober, after which I'll probably be back to playing some games. And it's been too long. Have a great Sunday, like I said.